Conventional foodwares, including spoon or straws, are mostly made of plastic, and these plastics could be further broken down by sea currents when they are released to the sea. These microplastics could be consumed by either sea turtles or other marine animals, including fishes, eventually consumed by humans and causing birth defects or even cancer. Therefore, me, Calvin,
and me, Hugo, aims to design, model, and test a low-cost eatable foodware subject to long shelf life and soft drink resistance in order to decrease the plastic's damage to the environment.
Coming up, I will be introducing the procedures for producing straws. First up, we'll be mixing the water, xanthan gel, and high-protein flour together in a mixing bowl and mix them until they are strong enough. Then we'll flatten them up and cut them into 2 cm x 2 cm pieces. And before baking them, the product will be like this, as shown in the video. Then we will bake them for the designated time. Finally, the product will be out and be exposed to air for 10 minutes before putting them up in an airtight container. And the product will be like this.
For the hardness test, weights of different mass was allowed to drop from a certain height onto the testing pieces. Pressure it can withstand is calculated as mg/A. For the drink resistance test, testing pieces are put in hot water over 80 degrees Celsius and cold water around 5 degrees Celsius. Also, testing pieces are put in commercial drinks, including Yakult and Coke, for 30 minutes. We'll observe if there's any precipitate in the solution, color faded from the pieces and changed in softness. Now, let's take a look at the results. All of the testing pieces can withstand over 100 kPa, while testing pieces baked in 150 degrees Celsius for 20 minutes with 120 gram flour can withstand the highest pressure of 318.2 kPa. Testing pieces baked in 180 degrees Celsius for 12 minutes with 140 gram flour has the best performance in the drink-resistant test since it has no precipitate, color fading, nor turning soft in all tests, except being softened in the hot water.
Throughout the project, it has been a pleasure to meet Dr. Marshall and other student advisors, giving us different knowledge about food science and the common testing for food products, also giving us a chance to develop our own recipe for edible straws. Even though we have some hurdles in how to scientifically show our data, we had overcome it by using the formula for pressure and also different criterions, eventually proving our product to be resistant to hot drinks and even soft drinks, sending our edible straw from other products.
During the whole session, I've learned a lot about food science, eatable cutlery, and several experiments and production methods. I really enjoy designing the straws and having various tests with my teammates and assistant. Although we faced many problems, including the expanded testing piece failed to be used in the pressure test, we successfully overcome it by choosing those flattened ones with no air inside. Finally, we would like to give a great thanks to Dr. Marshall, Dr. Chen, and other assistants for their kind and useful advices and help. Thank you.